Environmental Impacts of Space Exploration by Hannah Gray. Over the years, the thought of having our own colony on the moon or another planet like Mars has become a goal. However, how has this goal negatively affected our planet? Shouldn't we worry about our own planet before the thought of another one? Space explorations first started during the Cold War between the US and the USSR, fighting to see who could outdo the other. However, space exploration today has evolved to studying other planets and our own and how they work compared to Earth. Along with the newly emerging commercial space flights like airplanes, we're going to space instead. So how much is space exploration actually impacting the Earth? Depletion of ozone. Researchers have found that black carbon, soot, particles emitted by rockets are almost 500 times more efficient at holding in heat in the atmosphere than all the other sources of soot combined, surface and aircraft, resulting in an enhanced climate effect. Pollutants from solid fuel rockets and re-entry heating of returning spacecrafts and debris are particularly harmful to the stratospheric ozone. High temperatures during the launch and re-entry events can convert nitrogen in the air into nitrogen oxides, which can deplete ozone in the stratosphere. Scientists estimated that a fleet of 1,000 launches per year would cause ozone loss up to 6% in polar regions. Scientists warned that if left unregulated, rocket emissions could deplete the ozone more than ozone-depleting substances ever did by 2050. The depletion of the ozone layer could result in exposure to UV radiation for the people in the northern hemisphere. Climate impacts. Soot in the atmosphere can't be washed away by rain because it's too far up, trapping warm air, resulting in global warming, increasing annual temperatures in the stratosphere by 0.5 to 2 degrees Celsius, or approximately 1 to 4 degrees Fahrenheit. Exhaust can contain greenhouse gases such as CO2 and H2O, as well as black carbon. These types of emissions trap heat, absorb sunlight, and contribute to climate change and warming. Black carbon is defined by the EPA, Environmental Protection Agency, as a major component of soot with a complex light-absorbing mixture that also contains organic carbon and is a solid form of mostly pure carbon that absorbs solar radiation at all wavelengths. According to scientists, some rockets can emit approximately 10,000 times more black carbon particles than modern turbine engines found in airplanes and jets. Put into perspective, scientists also predicted that in 2018, the amount of black carbon emitted by rockets into the stratosphere was comparable to that emitted by the entire aviation industry. Overall, scientists have estimated that rocket emissions contributed to the warming of the stratosphere were caused 70% by black carbon. This indicates that rockets emitting black carbon are responsible for harmful warming impacts. Scientists estimate that just 10 years of launches at a rate of 1,000 per year, typical for space tourism applications, could cause a surface temperature rise as much as 1 degree Celsius. While the current amount of greenhouse gases emitted by rockets is relatively low, these are potential impacts as the industry continues to grow. Space junk. Orbital debris is any human-made object in orbit about the Earth that no longer serves a useful function. Such debris includes non-functional spacecraft, abandoned launch vehicle stages, mission-related debris, and fragmentation debris. In fact, a millimeter-sized orbital debris represents the highest mission-ending risk to most robotic spacecraft operating in low Earth orbit. There is over 1 million objects larger than a marble in orbit around Earth and 330 million objects larger than 1 millimeter. Objects orbit Earth so quickly that something measuring just 1 centimeter wide can expend the energy of an exploding hand grenade upon impact with a satellite. Soot and other particles generated by satellites putting up when they fall out of orbit are also growing. It's not like there's trash cans in space, so essentially we're littering, but in space. The rising population of space debris increases the potential energy of all space vehicles, including the International Space Station and other spacecrafts with humans aboard, such as SpaceX's Crew Dragon.
We've been sending satellites to space for over 60 years. So far, we have sent over 11,140 satellites in Earth's orbit. Out of these, 3,372 satellites are currently active. The rest are inactively floating in our orbit. The number of satellites has increased drastically over the past few years. In 2020 alone, 1,283 satellites were launched into lower Earth orbit. This is the highest number of satellite launches in a year to date. Now the low Earth orbit is about to become even more crowded. Over the next few decades, SpaceX is hoping to send a constellation of 42,000 satellites. Amazon's Project Kuiper, OneWeb Corporation, China's Hongyan, and Canada's Telesat are also planning on placing thousands of satellites of their own in the Earth's orbit. All that space traffic can lead to a disaster.
In 1996, a French satellite was hit and damaged by debris from a French rocket that had exploded a decade earlier. On February 10, 2009, a defunct Russian spacecraft collided with and destroyed a functioning U.S. commercial spacecraft. The collision added more than 2,300 pieces of large trackable debris and many more smaller debris to the inventory of space junk. China's 2007 anti-satellite test, which used a missile to destroy an old weather satellite, added more than 3,500 pieces of large trackable debris and many more smaller debris to the debris problem.
Now, with tens of thousands of satellites traveling around 17,000 miles per hour, the chances of these satellites getting close to each other are a lot higher. Collisions between high-speed objects in orbit can create thousands of pieces of debris. This could result in a chain reaction where more and more objects collide and create new space junk in the process, to the point where Earth's orbit becomes unusable.
Current environmental regulation of launches is mainly under the National Environmental Policy Act. NEPA requirements include environmental impact statements for launch sites, land use, air quality, soil, water quality, offshore impacts, biological resources, hazardous waste. Some effects are not considered through categorical exclusions. Consequences: global warming and climate change, along with flying objects that could fly in from space and impact the Earth, depletion of ozone, very unhealthy radiation, skin cancer, and weakened immune system, and as well as disruptions to agriculture and ecosystems. Possible solutions. Number 1, environmental regulation other than just on launch sites. This would be cheap, government-controlled, and companies would be regulated to change their rockets. The solution is likely to work with companies that follow the rules and other countries would follow suit. Number 2, design rockets to reduce the amount of pollution emitted. This is currently being researched with the idea of reusable rockets mainly being researched by SpaceX. However, this costs a lot due to having completely redesign and do testing with new rockets, so many companies may not switch over due to the cost and low amount of research. And finally, number 3, find a new way to clear up some of the space debris from orbit without creating more debris. This will cost a lot, there isn't much research, and it has been tried, but that just ended up creating more debris. However, there is been some rumors and a little bit of research with the usage of lasers. And I believe that each company sending debris into space should be held accountable for their debris and cleaning it up. My prediction is that as commercial space travel grows, the effects of it will grow too. I believe that once the impacts are way more noticeable, such as temperatures increasing, the research to stop it will begin. Or once diseases from depletion of ozone start appearing more often in polar regions. I also believe that the solution that will end up happening will be the new regulations due to it being less expensive for countries, but making companies switch to new rockets, which would decrease space travel until we have a new, better, and cleaner way to have space exploration. Special thank you to the NOAA research, the Georgetown Environmental Law Review, the European Space Agency, NASA, the University College of London, the Technical University of Braunschweig, and the University of Central Florida.